welcome back. So in this video, we are going to understand the LeetCode problem number 1689, partitioning into minimum number of Deci-Binary numbers. So imagine I have given you a number like 8200 like this something, right? And I will tell you that build it using number made of zeros and one. So if the digit, let's suppose for in this case I'm talking about 82,734, right? If this number I'm giving you, okay, and I want you, I will tell you to build it using only numbers made of zeros and ones, okay. And how many such numbers do you need at minimum? So the most people always thinking that this this how they will do the logic. Is it tough questions? How to break it? But it's just one line of logic. So let's try to understand how to implement this type of problem. So very first, let's go with the problem statement here. Understand what we have given here, okay. So the question that we are talking about is 1689. The question saying partitioning into minimum number of Deci-Binary numbers, okay. It means we are given a decimal number as string and we need to split it into minimum number of Deci-Binary numbers. So what is a Deci-Binary numbers that we should understand here? So let's suppose that it only contains digit either 0 or 1. So Deci-Binary number is a number that only contains digit 0 and 1. For example, if I'll say 1, 1 0, 1 0 1 and 1 1 1 0 0 0, something like that. So when we add them together, right, they must be equal to original number. So let's suppose if we want to add this one, we'll get some number. If we add this number, it will be some number. Like that, some number will come for each time, right? Some original number will come. We know that this is 1, this is 2, something like that. That is different thing that we will talk later, okay? So for example, let's take an example, okay. Let's take that we have given this 32, right? When we have given n equal to 32, so now think digit by digit here. To create digit 3, we need 1s here, right? To tackle vertically, we can say, right? Because each Deci-Binary number can contain almost 1 to digit position, right? 1 to digit position. So to form to form 3, right, you only need at least 3, correct? Same for digit 2 also. So you need at least two numbers. These two numbers you need at least. So what is the minimum overall, right? So the maximum digit that we have here is 3 digit, right? And minimum is 2. Understand? That is why I'll say the answer is 3. What did we say? Means to form let's start like this, okay. So basically we have given 32, and to convert or partition this into Deci-Binary number, right? Now how to think in digit by digit. It means let's create digit 3, right? So we know that if you want to create digit 3, you need 3 1s. How many 3 1s? Like this, 1 1 1, right? So if you need 3 1s, stack vertically, right? Right? It means because each Deci-Binary number can contribute at most one digit position. So to form 3, right, you need at least 3 number, correct? See, Same for this, you need at least two number. So the maximum digit is 3. And that is why our answer is coming 3. Okay? Means if you want for 3 2, for these 3 we need 1 1 1. For this you need what? Let's suppose if this is 0, you need 1 1. Means here you need how many? 2. Here you need 3. Like that you can say. Okay, and that is why the maximum digit is for 1s is 3. Okay, so this is what we need to do, guys. Saying that. Okay, let's try to understand what the question is saying. Okay, the very first it is saying that we have given a number, right? A decimal number as a string we have given, right? So deci-binary number is the number where it contains either 0 or 1, that we have understood. And there should not be no leading 0, no leading 0 also. For example, that we have talked about is 1 1 0 1 1 1 and something like that we can say, right? So deci-binary is the deci-binary number is a number that contains only digits 0 and 1, no leading and no zero leading, right? No leading zeros, and these are the example. So you must split the number into the minimum number of deci-binary number such that it will do the sum of all deci-binary, right, numbers. It should be equal to n, right? So we have to split this number, right, into minimum number of minimum number of deci-binary numbers. Okay, I hope you understand. Means we have given this n, and we have to convert this, we have to split this number into minimum number of deci-binary numbers. And so after you have to return this minimum count. Understand? This is what we have to do. So let's try to understand the. So basically, if we'll talk about what is important here, is the very important thing that I am understanding here is we have to, in a very simple term, if you say, the answer is very simple, guys. Means the maximum digit in the number. Keep it very simple. This will be our answer. Means the maximum digit in the number that we have saw already. Okay, so this is the our answer. So what is that true, right? That we shouldn't. Why is that true, right? So think about, each digit is independent, right? That we have talked about n equal to 32. So when we talk about n equal to 32, so look at the digit. There is two digit, 3 and 2. To build these 3, you must add 3 1 vertically, correct? 1 1 1. So these are 1s. We can say 1s. These are 1s. So how many 1s are there? So total 3 1s is there. It means how many is needed? If we'll do the sum, we'll get 3. So you cannot form these 3, right, fewer than the 3 deci-binary numbers. That is why I'm saying the maximum. So the maximum digit determines the minimum count, right? So we'll say the maximum digit in the number is our answer. And so in this case, output should be 3. As you can see here, output should be 3. So let's break it down a little bit more. Okay, so let's try to understand in very simple term. Let's suppose that we were talking about n equal to 32, correct? When we have given n equal to 32, so it is in the string form, correct? So in very simple step, we can say the step 1 will be like it is 10. Step 2 will be is 10. Step 3 is 1. This 1 2 is not allowed. Why? Because 2 is invalid. Can we say that? Let's so instead of, we can say that if you want to do the sum, we want to find the 32. If we want to 10, 10 and 12, right? If we want to do the plus plus, that is what I'm trying to do. It means this will not work because 2 is invalid case. What will be the better case? Better case, if you'll think about, let's type better thing, better approach. If we want, okay, go with 10, 10 and 12, right? It's still not correct approach. Even actually correct thing that we are talking about is, let's suppose we will go either with this 10, 10, 10, 10 and this, right? So this will not break, this will not work down, right? You must need only zeros and 1 is a digit. If we'll take any approach that contains 2, right, it will not work. As simple as it is. Then how will it work, right? Let's understand. So we must distribute the digit wisely. Let's suppose if we'll say distribute digit wise, digit wise. It means what? We have first digit 3 and we need 3 ones, correct? Then we have digit 2 and we need 2 ones. If we'll construct it, we can say, let's construct it like this. We'll say 10, 10 and 10. It gives you 30. Can we say that like this? Now think that we have now we need extra 2 for second digit, for 2 second digit, we can say. Okay guys, digit. How? 0 1 0 1. We will get what? 0 2, like this. Like that I'm talking about, guys. Okay, it means total. If we have to find, how we can define? See, as simple. We thought that 10 10 1 0, not 10, we can say 10 0 10 0 1 0 0 0, right? Then 0 1 and 0 1. Now do plus 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 plus. If you'll do, you'll get 32, right? So like that we need to find, right, the given n. So we can merge smartly also. Let's suppose how we'll do the smartly. If you want to do the smartly, how we can do that? So this way you have found the total, guys, right? Now we find the total. How smartly we can merge. Let's understand. Very first we'll say 1 1 1 1 and 1 0. That is why I was saying like this. So we'll get here 3 and 2. If in both case, if you see, answer is 3, because the equal max digit is, right, equal max digit in both cases is 3. Maximum one is coming is 3 in both cases. Maximum digit, you can say maximum digit is 3. So I hope you have understood, right? Let's take some bigger example so you can understand easily. Another was given n equal to 82734, right? This was given. So the digit what we have here is 82734. Can we say? So these are the given digits. These are the digits we have given. What is maximum? This is called maximum here, right? So maximum digit is nothing but 8. Can we say that maximum digit is 8? So answer is also 8, because to construct digit 8 we need 8 layers of oneness. Understand? If we want to construct 8, we need 8 layer of oneness, and that is why our answer is 8. I hope you are understanding clearly that what I'm trying to say here, right? So in this case, let's suppose that if we will find, let's suppose in this case, if we'll find here very first is, these are these are the thing we have given. Let's try to understand how we'll move our pointer to a scan. So as let's suppose the thing we have given here is 8 8 2. If I'll write 0 1 2 3 and 4 like this, okay? So these are the index we can say of the given string, and max we know that we have 8 here, right? So what we will do, if we have the max, we'll keep checking. This is the first max we will got, but keep moving ahead here till if we'll find any max. So we got 8 here, and if we'll keep moving ahead we will not get more than 8. So max will be 8. Our 8 will be there. So we need only one pass, right? We'll start I equal to 0 index, and we'll go till this 4 index, last index, and this 4 in generic cases it will become n, 0 to n minus 1, n minus 1 we can say, not 0 to n minus 1. And in all cases we'll keep looking for the maximum. If maximum, for this case maximum is 8, so if any other element comes more than 8, that will be our maximum. And so we got, because we are taking one pass, we are needed, right? It means the time complexity will become O of n, and we are storing some value here in a time, a special what you call, the space count will be O of 1, because it's constant. We will not took any storage here, right? We will just take the in the variable and will store here, and it will work, right? It means what is the intuition here is, right? Let's write here. Intuition is very important, guys. Okay, understand. Can we say that the each deci binary, means decimal binary number constitute or forms one most what do you call, at most each deci binary number constitute at most what, one per digit position, right? One digit position, right? So to build to build, let's suppose any digit d, right? We need at least d numbers, correct? Means 8 means 8, 4 means 4, like that we can say that. It means the minimum that we are talking about, minimum number required is, required is the max digit max digit in string. Max digit in string. As simple. So we should understand this, how to implement it. Okay. So whenever we talk about the minimum number required, it is the maximum digit in string. Okay. Let's try to run through the code so you will understand clearly. Okay. Let's keep. You can pause here also and you can try by yourself. So let's start that we have given string n, right? So it means we need to do something, right? And what we need to do, we have to find the max digit and then we will return. So let's start with the max digit, and this max digit start from the 0. If n is 0, we can return 0, right? So let's say we'll return this max digit. Okay, this is what we want to do. Here we will write the logic. So very first we have to go for all the characters, right? So we'll say char c, and we can get, let's suppose given a string is n, we can convert into to a string. How we'll do that? Not to a string, to char array. In character array, if you want to do, to char array is the function, right? In Java, you can do it. So once you will make string dot to array, it will get converted into character array, and from the character array you will get one by one character c. Understand? Now we'll say int digit is, let's suppose we want to check the digit, right? Like this. If we will do this, we'll get the digit, right? So we have to update the digit. Max digit is math dot max, and we can check what is the max digit currently we have and what is the current digit is there, right? Digit like this. So like this we can update our max digit, right? So like this you have to update our max digit. What is the max digit is here? Okay, now we have to do early early stop optimization. Why? So it will not go in the big loop, right? What is the maximum loop here? We know that we don't need to move ahead or finding the array. We can do optimization code also here, right? How? Think. We can, till now it will work, right? If you submit this code, it will work. But if you want to do the early stop optimization, means we don't need to scan the entire array. It means we have to make some condition. What is the condition is here? If the max digit is equal to 0, in this case we'll return 0. Understand, guys? Let's try to check why we have taken, oh sorry, not 0, I'm thinking something, writing something, 9. Okay, see the code was working fine, but if we'll write the 9 will be the maximum digit, right? And so because we are taking one by one integers, what is happening? Return 9, not 0. Okay, let's try again. See, it will work. Let me submit. The code has been accepted. Why? Because we know that we have taken n will be given, let's suppose in 3 2 we have given. So in this case, let's suppose if we'll scan from here, we'll keep going ahead, we got the maximum, right? Let's suppose some number will be there, let's suppose 1 2 3 4 5 6, right? If any value is there 9, right? If we already got this n equal to 9, so in this entire value, if you see, either the 9 will come here, right? Or less than 9 will come. It means we don't need to go here entire scanning. We can directly return from here that this is the maximum digit is 9. Okay, and that is why we have to do some optimization so that the entire array, we know that we are scanning from here to here. If we'll find anywhere the 9, anywhere any index, from there we will break that, we will stop the scanning and will not do anything else, right? Because we'll optimize the code like this. So that's all I have in this video, guys. You know that the time and space complexity space, we are not taking extra spaces, or it is constant. And for time it is O of n, because if the 9 is not there, right, it will still take O of n time. So that's all I have in this video. If you like this video, please hit subscribe to this channel. In case you are seeking or learning DSA, Java, React, or any full stack development if you want, and system design, please reach out to me through the WhatsApp, and you can have enrollment in our online classes. So that's all I need this video. Please hit subscribe this channel, share with your friends, and please keep supporting Expert Hunter.
Thank you guys. Thank you for watching this video. If you found this video helpful, please like, subscribe, and let us know what you want to learn next in the comment below. And thank you for watching this video.